Hi, I'm Carl, and in this video we're going to be looking at questions 7 to 9 of section 3 of the blue booklet. So this is a question about a ball sliding down a curve. We're given quite a lot of information, but I've copied out the diagram here. 7 says, as the ball slides down the curved surface from point R to point T, the total mechanical energy, which is the sum of the kinetic and gravitational potential energies of the ball, increases or decreases or stays constant or changes. Okay, so the law of conservation of energy says that energy cannot be created or destroyed. And in an example like this, at point R, the ball will have a lot of gravitational potential energy, and because it's not moving at this point, it will have no kinetic energy. This gravitational potential energy pulls the ball down the slope and converts into kinetic energy as the ball speeds up down the slope. The mechanical energy is going to be the sum of the kinetic and the gravitational potential energies. So as one is converted into the other, the whole mechanical energy just remains the same. So that means the answer for number 7 is going to be C, that it remains constant. And this is just due to the law of conservation of energy. Question 8 says the decrease in gravitational potential energy of the ball as it slides from point R to point T is closest to what? Okay, so it starts off at R and it ends up at T, and we'll just draw in a circle here. Let's work out the gravitational potential energy at R and then again at T, and we'll take them away from each other and see how we get. So I'll just get rid of this to give us some more room. So at R, the gravitational potential energy is going to be the mass times the acceleration due to gravity times the height. Now the height here we're told is 10. An important note for this question is it's not the height of the ball, it's the height of the center of mass of the ball. Now here it is still going to be at 10, but when we get down to T, it'll be a little bit different, and I'll show you why that is when we get there. Okay, so the gravitational potential energy at R is going to be the mass, which is 0.05 kilograms, times 10 for the acceleration due to gravity, times the height, which is going to be, again in meters, so 0.1. This gives us an answer of 0.05 or 5 times 10 to the minus 2 joules of energy at R. Now at T, I've not drawn this very well, the centre of mass is going to be here. So let's work out some of these heights. So we know that the angle of curvature, or the radius of curvature, is going to be 8 centimetres. So what that basically means, if you were to draw a circle out of this curve here, the circle would have a radius of 8. So we know that the difference in height from R to T is going to be 8, so that means the height here is going to be 2 centimetres. We also know that the radius, or the diameter of the ball, is going to be 2 centimetres. We're told it's a solid ball, so we can assume it's uniform, and that means the centre of mass is going to be a further 1 centimetre up, so that means the height at T for the centre of mass is going to be 3 centimetres. So the gravitational potential energy at T, again, is going to be the mass times gravity times the height. The mass stays the same, so it's 0.05. Gravity stays the same, it's 10. And then the height here is going to be 0.03. That then gives us an answer of 1.5 times 10 to the minus 2 joules. So we're asked what the decrease in gravitational potential energy is, so we can just take them away from each other. So we've got 5 minus 1.5. Because the indices are the same, we can just leave those out. So that is going to be the decrease in the gravitational potential energy, meaning the answer for this one is going to be C. And then finally, for question 9, we're given quite a lot of information, and it basically says this structure here can slide along a table, and it's got a mass of 500 grams. Everything else is the same, and what happens to the total mechanical energy of the ball if this structure is able to move. So there's a couple of different ways of doing this, and you could try doing some calculations, but I think it's easier just to think of it as the ball is going to be moving down and exerting a force on this structure. And because it's a curve, it's going to produce this lateral force in this direction. So when the ball moves down here, it's got a weight, and its weight is going to be met with a reaction force. And that reaction force is going to be equal to the force driving the movement of the structure left and right along the table. If there is a force being exerted on the structure that causes its movement, some of the potential energy or the mechanical energy of the ball is being used to move the structure, which means that the mechanical energy decreases only. So the answer for number 9 is going to be A. But I'm going to go over the other answers just to explain why we can rule them out. So B can be ruled out due to the law of conservation of energy. Energy wouldn't be added to the ball here if the structure is able to move freely below it. C says remains constant. If the structure was fixed in place, then yes, it would remain constant. But given that they're both free to move, that means that they can transfer energy to each other, and the forces that they exert on each other can cause movement. And that wasn't the case whenever we had to answer question 7. And then D says first increases, reaching a maximum at S, and then decreases. So the issue with this one is that S is sort of the halfway point between R and T here. And remember, the mechanical energy is going to be the sum of the kinetic and gravitational potential energies of the ball. It's not going to first increase and then reach a maximum at S and then decrease. We discussed in question 7 why it wouldn't increase, because this kinetic energy is being generated from the gravitational potential energy. So if you added them up, they're not going to increase, because as one increases, the other decreases equally. 1 joule of one is converted into 1 joule of the other. That means that it would normally stay the same, so it couldn't increase. But given that the structure is able to move, and let's say the ball is moving here now, the ball has a weight and you get a reaction force then perpendicular to the plane at that point, you get movement of the structure beneath it, and that movement requires energy, which takes away from the mechanical energy of the ball, which means that there's going to be a pure decrease in the mechanical energy of the ball. So the answer for this one is going to be A. So that was question 7 to 9 of the blue booklet. I hope that helped. Thanks for watching.